For several weeks now, we've worked on making graphs and tables when you are given an equation. Today, we're going to work on going the other way. We're going to work on writing an equation if you are given a graph or a table. We're going to start with our graphs first. If you'll turn to example 1 or start on example 1 in your notes, we're going to have an equation from a graph. In order to write an equation from a graph, you have to first find the slope and the y-intercept. We are going to write all of these in slope-intercept form. So our first graph has a y-intercept at 1. Our y-intercept is written as an ordered pair, 0, 1. And our slope is rise over run, so I'm going to pick 2 points. This is rise 2, run 1. So our slope is up 2, right 1. Rise 2, run 1. Now, remember, we're going to write this in slope-intercept form, which is y equals mx plus b. Our m is 2 over 1, which also equals 2. We can reduce that. And our y-intercept is at 0, 1. So in slope-intercept form, we would write y equals, we're replacing the m with 2x, and then we're going to replace the b with a positive 1. So the graph of this line in slope-intercept form is y equals 2x plus 1. Okay, taking a look at our second example, we have a graph that has a line on it. We're looking for the slope and the y-intercept. It's very easy to identify the y-intercept. It's where it crosses the y-axis, so it's right here. Our y-intercept as an ordered pair is 0, 2. Our slope is rise over run. We pick 2 points. This time we go down 4. If we go down, that's a negative 4, and then we go to the right 1 space. Negative 4 over 1 is equal to negative 4, so our slope is negative 4, and our y-intercept is at 2. We're going to write this in slope-intercept form, and in slope-intercept form, it's y equals mx plus b. So we're going to replace the m and the b with the numbers we found from the graph. Our slope-intercept form is y equals, our value for m was negative 4, that's our slope, and then we have our x. Our b value where it crosses the y-intercept, the beginning of the graph, is at positive 2. So slope-intercept form for this problem is y equals negative 4x plus 2. So as you can see, it is very easy to write slope-intercept form from a graph. You only need to know 2 things, and those 2 things are the slope and the y-intercept. Y-intercept is always the point where the line crosses the y-axis, and the slope is always your rise over your run. Alright, the next thing we're going to do is we're going to write equations from tables. We have x values and y values. In our x and y values, we have to have a constant change in the ratio of x and y. Doesn't mean that they're going to have the same number each time, but it means there will be a constant change for the ratio. Looking at these, we have negative 2, 0, 2, and 4 on our x values. So the x values are increasing by 2 each time. These are plus 2, plus 2, plus 2, plus 2. The y values, we have 5, negative 3, negative 11, negative 19, and negative 27. So our y values are subtracting 8 each time. 5 minus 8 is negative 3. Negative 3 minus 8 is negative 11. Negative 11 minus 8 is negative 19. And negative 19 minus 8 is negative 27. Our slope, remember that slope from a table is the change in y over the change in x. It's always our y values on top. So our change in y was negative 8. Our change in x was plus 2. Negative 8 over 2 is a negative 4. So the slope of this line is negative 4. Now in our process, our slope will always be what we multiply by x. So in our process, we would have negative 4 times negative 2. Now negative 4 times negative 2 is a positive 8. In order to get to 5, we subtract 3. If we try the next one, our slope, our negative 4 is always going to be what we multiply by. Negative 4 times 0 is 0. To get to negative 3, we'd have to subtract 3. Negative 4 times 2 is negative 8. To get to negative 11, we would subtract 3. Negative 4 times 4 is negative 16. Negative 16 minus 3 is negative 19. I'm trying to get to my y values. And the last one, negative 4 times 6 minus 3 is negative 27. This table makes it easy on us because we can see our y-intercept. Our y-intercept is where the x value is 0. So our b is at 0, negative 3. That's where this would cross the y-axis on a graph. Slope-intercept form is y equals mx plus b. Now, in this equation, we would have y equals our slope, our value of m is negative 4. Then we put our x. Our beginning value, or our 0 value, is at negative 3. So we would have minus 3. Notice that in our equation in our table, we have our x values multiplied by 4, which is exactly like our slope-intercept form, and then we were subtracting 3 each time, which is exactly where our y-intercept is. Your slope-intercept form should match your process. Those are the same. We kept our negative 4, we multiplied it by our x values, and then we subtracted 3. For our last example, our second example for writing equations from tables, we're going to do the same thing. Notice this time in our table we don't have our y-intercept showing, we don't have our value of x, so we're definitely going to need to use our slope to help us find that. Our change in the x values, we go from 3 to 4, 4 to 5, 5 to 6, and 6 to 7 is plus 1. So our change in x values is plus 1. Looking at the change in y values, this is plus 3. To get from 4 to 7, we're adding 3. To get from 7 to 10, we're adding 3. To get from 10 to 13, we're adding 3. And from 13 to 16, we are adding 3. So our slope is change in y over change in x. Our y values are increasing by 3. Our x values are increasing by 1. So 3 is what we're going to multiply by. Remember that your slope will always be what you multiply x by. Now looking at our process, we have our 3 times our x values. So 3 times 3 is 9. We're trying to get to 4. So 9 minus 5 is 4. We're going to try the next one. 3 times 4. Well, 3 times 4 is 12. To get to 7, we'd have to subtract 5. And then 3 times 5 is 15. To get to 10, we'd have to subtract 5. 3 times 6 is 18. 18 minus 5 is 13. And 3 times 7 is 21. 21 minus 5 is 16. Now, our beginning value is always the number that is added or subtracted when, we are looking at our process. So our y-intercept in this problem is 0, negative 5. It's the number that's added or subtracted in our process. Slope-intercept form is our process. We have y equals, every single time we had 3 times our x value minus 5. So we've written our table values in slope-intercept form, y equals 3x minus 5. Be ready tomorrow and Wednesday to work on slope-intercept form from tables and graphs. We're going to work tomorrow on graphs, and on Wednesday we're going to be working on tables.